A new topic that is investigating data. And the first thing we're going to look at is this concept of a sample versus a census. And basically, by the end of this lesson, you should know the difference between a sample and a census, determine when it is more appropriate to use a sample or assessment or a census, and determine if a method of choosing a sample is appropriate or not. So I'm going to explain that in more detail as we work through this here. Before I get too far into the concept of a sample versus a census, I'm just going to talk a little bit about what is data in the first place. So data is essentially a collection of facts or information about a topic. So data can be collected in lots of ways. We can collect numbers, we can have survey questions, there's all different things we can do to collect data. And data collection is actually really important for a number of reasons. So first of all, often when data is collected, we need to actually do something with it to help it be relevant and help us make sense of it. So some of the things we would do is organize it, and we're going to look at this organization, including organizing it in a dot plot, stem and leaf plot, what's called a frequency table, histogram, and polygon. So they're all things we're going to look at. You probably would have looked at some of those in the past and some of them maybe not. From there, we then also need to analyze it to help us better understand what it's actually telling us. And ways we can analyze it include finding the mean, median, mode, and range, which are all things you would have done in the past, as well as some extra ones, including the shape and the interquartile range. Now, data is then often displayed in a variety of ways that make it easier to read and understand. So there might be things like sector graphs, pie charts, column graphs, as well as another one that we're going to look at this year called a box and whisker plot. Often these displaying methods in the real world are done digitally, but it can be useful to know how to do it by hand so you kind of do understand where the digital one is coming from. With all of this in particular, the analyzed data, can then help us make more informed decisions, support arguments, and it can be used in lots of ways. And often this is a key area of mathematics that is used not only in just maths, but across a number of other subject areas. So for example, if you were writing an essay, you would potentially use data to support what you were saying. If you were doing something in science and you had conducted an experiment, you would analyze your results at the end to help support whether what you were investigating was reached or not. So this is a very big cross-curricular area of maths. So we're looking at a sample versus a census. Now, I don't know why that went so small. I might zoom in when I go over it there. So when we have data, the population refers to the whole group that data collection is relevant to. So it looks at the whole group. A census is when the whole population that is involved is surveyed. Now, depending on what our population is, that might be expensive or difficult to conduct. So, for example, we just actually had a census this year for the whole Australian population. Now, we only do that every 5 years because getting that information about the whole population is challenging and very expensive to do. You must conduct a census, though, when you need exact numbers. So if what you're looking at, you need exact numbers, so like the Census of Australia, when they're trying to work out exactly how many people in Australia, how many people do we have living in this area and how many people do we have living in that area? We need exact numbers, so a census would need to be taken. A sample is then when we have a smaller group selected out of the population. A good sample should be a fair representation of the population. And to ensure this, there's a couple of things that should happen when a sample is chosen. It should be randomly selected or selected in another valid way that still means kind of everyone has a chance of being picked. It should be free from bias, so one group within it shouldn't be favoured. And bigger samples are always more accurate. So the bigger your sample can be, the more accurate it would be. So just to explain that a little bit more, I'll just zoom in here. Let's say that OLSH is investigating our students' experiences on remote learning. I need to make that a bit smaller. So in that case, the population would be all the students in the school. So if I was to take a census when I'm trying to investigate the experiences of OLSH on remote learning, I would need to survey all the students in the school. Now, realistically, it's probably not necessary to take a census in that case because I don't need exact numbers. I don't need exact figures. If I was investigating something that did require exact numbers, and that might be, for example, how, I'm trying to think, the number of people that use the 309, that catch the 309 to school, in that case, I would need to take a census because I'd need exact numbers for the bus company. But something about their opinion on remote learning or your experience on remote learning, I don't need exact numbers. A sample would give me a good enough idea about what's going on. So examples of good samples would include 100 randomly selected students. So I put all the names of the students in a hat and I pull out 100 of them and then I survey those students. That would be a good sample. Another one might be 20 randomly selected students from each year group. So I would have around 100 students by doing that method. I'd have 120 because we have, I don't have 100 still, because we only have 5 years at this school. And that would still has an element of randomness as the 20 students I'm picking in each year group are randomly selected. And that's actually a specific type of sample called a stratified sample where each group is kind of in the group is considered. If you do standard maths next year, you'll learn more about that then. But it's still a good sample because it's got a good spread of the population and everyone is fairly represented. Examples of bad samples in this case would include surveying year 7 only. So if we only surveyed year 7, the type of work year 7 are being set is probably very different to what you might be experiencing in year 10 or the year 11 and 12s are experiencing. So if we were to survey year 7 only, it's probably not going to give us a really good idea or a good understanding of what the whole population of OLSH's experiences on remote learning were. Another one might include surveying the SRC only. Now, yes, that does cover all the year groups, but if all those people are on the SRC, those people probably do have some similar qualities in their personality in that they've put themselves up to be an SRC member in the first place. So they may have more similar opinions than the actual whole student population would have. So again, that wouldn't be a great sample or even really a good sample, because it's not going to give us a good understanding of the whole population if we ask only that type of person or those people that, have put themselves forward to be an SRC member. I've also said even a sample of 20 students. That wouldn't be a very good sample for OLSH because we have 850 girls in the school or students in the school. If I only take a sample of 20, I'm again probably not going to get the best understanding of how people have found remote learning by only selecting those 20 students. Whereas when I'm getting bigger and closer to 100, I'm at least getting a good idea then. Okay, so coming down to our example now. First of all, we are looking at would a sample or census be used for the following. So the first one is the most popular TV show in Australia. Now, in this case, this is more of an opinion-based thing. I don't need an exact number to determine that. Okay, it's an opinion situation as well. So I can just use a sample in this case, and that's it. Whereas for B, we're asked for the number of retired people living on the Gold Coast. So number tells me that I need something exact, which tells me I realistically would need to use a census to do that. And that's something that, the Australian government probably did survey or may survey as part of a census, or they might have to do a special census in the Gold Coast to work that out. And they might need exact numbers because they're looking at building more retirement homes or something like that. So the more exact we can be, we would need exact information there, so we would need to use a census in that case. Our second example here tells us a random sample of students is selected for their views on a new school uniform. Will these following sampling methods provide one that is a good representation, so representative, or biased, so one that is not very well representing all the students in the school? So our first one has randomly selecting one student from each class. So they go to each homeroom in the school and randomly select one student from the homeroom. Overall, that will give us quite a representative sample, as it is someone from each year group, but they've been randomly selected. So that's different to that idea of the SRC that I spoke about before, because with the SRC example, that was all people that had put themselves forward to be SRC members. So they have some similar qualities in that respect. Whereas this situation, it was a random selection from each class. So all different types of people and all different personalities are going to be included in that sample, hopefully. Now, it is possible that there could be a fluke and, you don't get a good spread of people from each of those selections, but it's more likely that you're going to get a good spread of people there. Our next one is just selecting students from the school's netball team. Now, that would be biased because everyone didn't have a fair chance of being selected. It's biased towards that group of the netball players. All those people in the team might prefer a certain type of uniform. They might all say, we want a new school uniform that's more like a PE uniform, so it's easier for us to play netball in. And that's not what the rest of the school may prefer, or lots of other people in the school might prefer. So that would be a biased sample. So remember with this, if we're thinking, should it be sample or census, basically think, is it opinion-based or is it more about the exact numbers? And then if we're thinking, is a sample good or not, basically, was it fairly selected? Did everyone have an equal chance of being selected? That would be a representative one. If not, it's biased. Thanks, girls.